In today's video, we're going to be reviewing over exponents and exponential terms and operations with exponents and scientific notation. So first, let's get down the basics. What is an exponent? All right, so an exponent is a little number in the top right corner. In this case, it would be the 3, where it tells you how many times you're multiplying a base, in this case, which is 2, how many times you're multiplying that base by itself. So 2 to the third would be equivalent to 2 times 2 times 2, which is 8. All right, so you have a base, and the exponent is a little number in the top right. Okay, now you can add exponential terms. You could subtract exponential terms. You can multiply and divide them. But it's important when you're doing these and you're doing these operations that you recognize it only can happen if they have the same base. So, for example, if I had 2 to the third and I wanted to multiply that by 2 to the fourth. 2 to the third is essentially, right? Remember, 2 times 2 times 2. 2 to the fourth is 4 of them. 1, 2, 3, 4. How many 2's are there total? There are 7 2's. So basically, you're multiplying 2 by itself 7 times, or taking 2 to the 7th power. A quick shortcut on how to do that is you keep the base, which is 2, and then you add the exponents to get to the 7th. All right. Now let's look at another example of a different operation. Let's say I had 4 to the 7th divided by 4 to the 3rd. Change that. 4 to the 2nd. All right, division. All right, so if I wanted to write this in a different way, you would write it as a fraction. So you have 7 fours, 1, 2, 3, 4, 5, 6, 7. On the bottom, you would have only 2 of them. Remember, whenever you have a number divided by itself, it cancels out to 1. And then you're left with this on top, which is 4 to the 5th. But another shortcut we could get from that is by keeping the base and subtracting the exponents. 7 minus 2 is 5. So when you multiply terms with the same base, you keep the base, add the exponents. When you divide terms with the same base, you keep the base and subtract the exponents. All right. Now, say I had the other way around. Do this. Instead of 4 to the 2nd divided by 4 to the 7th. So we would have 2 4's up top, 7 on the bottom. 1, 2, 3, 4, 5, 6, 7. So again, canceling out. Divide, divide. Looks a little bit different. The 4's are left over on the bottom. And there are how many? 5. So the 4s are left on the bottom. That stays on the bottom of my fraction, 4 to the 5th. Whenever I have a number divided by itself, it's always going to equal 1. So you can't just cancel them out to 0, so you're going to be left with 1 on the top. Now, if we used our shortcut rule, we would keep the base and subtract the exponents, and that would be 4 to the negative 5th. So that actually covers a different rule that we were going to cover, is when you have negative exponents. When you have negative exponents, they turn into a fraction where the base and the exponent go to the bottom, and there is a 1 left on top. So another example would be 3 to the negative second would be 1 over 3 to the second. 4 to the negative 6th would be 1 over 4 to the 6th. The same goes vice versa. If you have a negative on the bottom, so let's say I had 1 over 2 to the negative 3rd, this would then come up top and become 2 to the positive 3rd. Or if I had 1 over 5 to the negative 6th, that would come to the top, and that would be 5 to the 6th. So a negative exponent basically flips the base and the exponent in the fraction. And all numbers can be written as fractions by dividing them by 1. All right, so we covered multiplying terms of the same base, dividing terms of the same base, what a negative exponent means. All right, so now let's talk about multiplying and dividing some algebraic terms with some variables. So multiplying, say I had 3x to the second multiplied by 5x to the 6th. Whenever I'm doing these, the coefficients are different than exponents. So the coefficients are out in front, the 3 and the 5. What you do with those is you multiply those. Okay, so 3 times 5, which is 15. With the x's, remember the terms of the same base, you keep the base, which is going to be x, and then you add the exponents, which is 2 plus 6 is 8. So it'll be 15 times x to the 8th. All right, let's look at one where you divide. So when I divide, I'll write it as a fraction. 20 over 4 x to the 7th x to the 3rd. So with these, you divide, different color here, the numbers out in front. 20 divided by 4 is 5. Keep the base, and then you subtract the exponents. So that would be 7 minus 3, which is 4. And that would be your simplified answer. Now, in some scenarios, you might get a funky fraction that looks like this. All right. Now with this, same thing as before, you would divide the numbers out in front. So these we would divide or reduce. In this case, 20 doesn't go into 15, so we have to reduce it. So 15 divided by 20, those are both divisible by 5, and that reduces to 3 over 4. We keep the bases, right? X, keep the base of y's, and we subtract the exponents. So 5 minus 1, remember, don't forget, that's a 1 there, is 4. 3, different color here. 3 minus 6 is negative 3. So now we have a term with a positive exponent and we have a term with a negative exponent. Remember, in our fraction rules from up here, keep going up here, if it's a negative, it goes to the bottom of the fraction. All right. Whenever we have a negative term with a negative exponent, that part of it goes to the bottom. So this whole thing is going to go to the bottom of the fraction. The one with the positive exponent is going to go to the top. So when I simplify it, it's going to be 3x to the 4th over 4y to the positive 3. That would be my simplified answer. Okay, so those are the basics with operations with exponents. Now, let's get into scientific notation. Scientific notation. A number is written in scientific notation usually either really big numbers or really small numbers. So, for example, if I had the number 403, we add one more 0, 4. And I wanted to write this in scientific notation. First, you see where the decimal point is, find where the decimal point is, and you want to hop over every digit to get until you have right after the non-zero digit, which would be right here. Right after the first non-zero digit is 4. That's where I'm going to move my decimal point, 4.03. I'm not going to include the zeros after that because we just don't write out zeros afterwards. And then multiply that by a power of 10. And depending on how many hops I went, 1, 2, 3, 4, 5, 6 is the exponent of the power of 10. So it would be 4.03 times 10 to the 6th. Now, if I had a really small number, for example, 0.0000321. Okay. Again, reading from left to right, my first non-zero digit is 3, so the caret goes right after the 3. Count how many hops? 1, 2, 3, 4. So that's where I'm going to move my decimal point. So it's going to be 3.21 times 10, always a base 10, to the, now since I'm going, it's a really small number, it's going to be negative 4, and I hopped in the right direction. If a number is in scientific notation and I want to convert it out, for example, 3.1459 times 10 to the 5th, let's say that. The 5 tells you how many spots you're moving the decimals. It's going to be, since the positive is going to be a bigger number, so you're going to move it to the right 1, 2, 3, 4, 5 spots. So your number is 3, 1, 4, 5, 9, and any open hop gets a 0. Now, if it was a -5, let's erase this. Whoa. Erase. Say if this was a -5 instead, that means you would go 5 spots in the other direction. 1, 2, 3, 4, 5. There's my new decimal point. Every hop gets a 0. So it would be 0.000031459. So the negative exponent means it's a really, really small number. Positive exponent usually means it's a really big number. Now you can also perform operations with scientific notation. For example, multiplying. Say I wanted to multiply 3.2 times 10 to the 5th times, times 4.1 times 10 to the 7th. Kind of the same rules of how we did multiplying algebraic terms before. We would multiply the numbers out in front. So these numbers right here, we multiply. Keep the base like we kept the x's before. So we're going to keep these. Keep the powers of 10. And we are going to add the exponents. And then make sure our number is in scientific notation at the end. So 3.2 times 2.1. 3.2 times 2.1 is, or is it 2.1? 4.1. Oops. 4.1 is 13.12. So when I multiply those numbers out in front, I get 13.12. I keep the power of 10, so times 10, and I add the exponents. 5 plus 7 is 12. So we performed the right operations here. But what we notice is that this is not in scientific notation. So in order, remember, we want only one digit before the decimal, not two digits. In this case, it has two digits before the decimal. We want one digit. So we have to move our decimal point over one spot to get 1.312. Now I can't just move the decimal point over. I have to adjust my exponent. Still keep it a power of 10. Now since I made my front number smaller, the exponent has to be bigger. So once I moved that to the left 1, that means the exponent gets bigger by 1. So it's 10 to the 13th. Now that's a number in scientific notation. All right. Let's look at one where we divide. So let's do 6.3 times 10 to the 8th divided by 2.1 times 10 to the 5th. Now, this can look like this, or it could also be a fraction, because it could also look like this. So just be aware of that. Same rules kind of apply here, just the opposite operations. We would divide or reduce the numbers in front. So 6.3 divided by 2.1 is 3. We keep the powers of 10, so times 10, and we would subtract the exponents. which is 10 to the third. 8 minus 5, which is 3. This number's in scientific notation. There's the decimal. There's only one digit before the decimal. So it's 3 times 10 to the third. Now, let's say I wanted to add these. Okay, a little bit different if I wanted to add them. Let's see if I can do this quickly here. There we go. It's kind of quickly. And we're almost there. All right, so say I wanted to now add these instead. Adding is a little bit different than multiplying and dividing. You have to have the same exponents before you do anything. So this 8 and this 5 are not the same. So in order to do that, I have to get them to be the same. I usually try to catch up the 5, catch up to the 8. Or actually, the 8 catch up to the 5. It doesn't really matter what direction you go. Okay. If I want the 5 to catch up to the 8, that means I would have to make this number bigger. So I want this to be 10 to the 8th. So that means I have to make this smaller. So I have to move 3 spots. 1, 2, 3. So this would be 0.0021 times 10 to the 8th. And I don't know why I wrote that there. I could have wrote it over here. Because we want 10 to the 8th. And then this would be 0.0021. Now I can add these. I add the numbers out in front. 6.3 plus 0.0021 is 6.30021. Now the only difference with adding and subtracting, once you have the same base and the same exponent, is you keep this entire thing. So you keep both the 10 and the 8s. So it's times 10 to the 8th. Now this is already in scientific notation. So that's going to be my answer. Let's try one with subtraction. Really no difference. Let's do 4.2 times 10 to the 4th subtracted by 3 times 10 to the let's do second. So we want the same exponent. So I have to catch this 2 up to the 5. So I want it, to a 4. So I want to have 10 to the 4th. So that means I have to move this decimal over. If I'm making the exponent bigger, this decimal have to move to the left to make the front number smaller. 1, 2. So it would be 0.03 times 10 to the 4th. Now the difference with this is we're subtracting these. Remember, we're subtracting. So 4.2 minus 0.03 is 4.17. And again, you keep the base and the exponents when you're adding and subtracting. And that's already in scientific notation, so I don't have to adjust it at all. All right, so we went over a lot of different things. We talked about adding, subtracting, multiplying and dividing in terms of scientific notation. We talked about what an exponent is and how to multiply and divide algebraic terms involving exponents. And we talked about what a negative exponent means. So remember, when a negative exponent, it turns into a fraction and goes to the bottom. And what we're going to do in our review assignment is to make sure that we remember all these little intricate rules, and so you have this video to always reference to. So if you have questions in class, some of these things you might have to go back and watch the video on. Okay, if this went too fast for you, some of these topics might be a little, you have to go back to. But if you have any other questions, please let me know. All right, thank you for watching today's video.